In this video, we will discuss 2-stack PDA. A 2-stack PDA M is a 6-tuple. M is equal to Q sigma gamma delta Q naught and F. Q is finite set of states, sigma is finite set of input symbol. This is finite set of stack symbols, gamma. Q naught is the initial state and F is the set of accepting states, or we can say final states. The only difference between 2-stack PDA and PDA is that in PDA we have single stack and in 2-stack PDA we have 2 stacks. That's why in the transition function we have Q sigma, this is gamma for stack 1 and this is for stack 2. Similarly, here also this is for stack 1 and this is for stack 2. So the transition is in the form of, we are at some state, we read some symbol, the top of stack 1 is X, the top of stack 2 is Y. Then Q1 is the current state. Then we go to the next state or the new state, Q2. The top of stack 1 is replaced by X1 and the top of stack 2 is replaced by Y1. The idea of 2-stack PDA is that we have a string stored on an input tape. We start reading a symbol. We start with Q naught. We read a symbol. We move to some another state and we perform some corresponding operation on stack 1 and stack 2. Now, push and pop operations can be performed either individually on stack 1 and stack 2 or simultaneously. Means either we can perform pop and push operation individually, or at the same time also we can perform these operations. Push and pop operations can also be performed between these two stacks. Means we can pop some symbol from one stack and push that symbol onto some other stack. Means the content of stack 1 can be transferred to stack 2 and vice versa. We can achieve this using these transitions. We are at some state without reading any symbol. The top of the stack 1 is A and the second symbol is B under this A. Then we can transfer this top symbol to stack 2. So we may go to some another state or we may remain in the same state. Then what will happen? This top symbol is pushed onto this stack 2. Now the top symbol of stack 1 will become B. Here we are transferring the top of stack 1 to stack 2. Now if you want to pop some stack, look at this transition. We are at some state, we read some symbol. Initially both the stacks are empty and we want to push this symbol onto some stack. So in this case we are pushing symbol A on stack 1. That's why I have represented it here A and the stack 2 is empty. If we want to push this A onto stack 2, then instead of this place will be A and this will be epsilon. Now this is the push operation actually. Now if you want to pop some symbol, if you want to pop some stack, in that case we are at some state without reading any symbol. top of stack 1 is X, top of stack 2 is Y, then this symbol shows that we are popping stack 1. Okay, so epsilon is used to represent the pop operation here in this case. Next is configuration. Now configuration is used to show the acceptance of some string. It is 4 tuple, means it is consists of 4 components: Q, sigma, gamma star, cross, gamma star. This is for stack 1 and this is for stack 2. We may write it as gamma 1 star or gamma 2 star also. Now suppose the string W is AX, where A is the first terminal symbol of the string and X is the remaining portion. Then we are at some state Q0. The string is this AX. The stack 1 is, the top of stack 1 is X1 and the top of stack 2 is Y1. Then we consume this symbol. The remaining string is this. We go to the next state and this X1 and Y1 are replaced by X2 and Y2. So this is some configuration, and after performing some transition operation, the next configuration will be this. Now if Q0 is the initial state and W is the initial string, then the initial configuration will be, and it will be denoted as C0, and the initial configuration will be Q0 W epsilon epsilon, because initially both these stacks will be empty. Now the acceptance of some string can be represented as, we start with Q0. Initially the string is W. Initially these stacks are empty. After performing some operations, we go to the final state, and by that time we will read the entire string and these stacks will become empty again. Okay, so this shows the acceptance of the string, where QF is the final state. Now sequence of configurations can be represented as from configuration 0 to configuration n. Means here using C1 and C2 means we are applying some operations, right? So C0 is represented by Q0 W epsilon epsilon, and Cn is the last configuration. It shows the acceptance, it shows that we have reached the final state. So Cn will be represented as QF epsilon epsilon epsilon, means we have read the entire string and the stack 1 and stack 2 has become empty again.